Hello, welcome to the workshop again, and today we're going to talk about hum. Hum is always the biggest problem with transmitters. 70 to 80% of the time you should get away without any real problems, but occasionally, depending on the house wiring, location and various other things, you may experience hum. So I'm going to talk about what it is and potential ways of getting rid of it. So to begin with, we have to just look at a radio signal. Basically, a transmitter takes our audio signal like that and modulates it so that it can be sent over the airwaves. So to do that, the radio frequency gets bigger as the audio wave gets bigger, and then it gets smaller as the audio wave gets smaller, and so on. So at the receiver end, you have a detector which chops off the bottom half of that radio wave, leaving just the top half, and then a capacitor will smooth out the bumps of the top half, leaving us our original audio wave like that. Now then, a transmitter, as it is, would obviously radiate a radio signal. However, if you add a ground to a transmitter, it becomes more efficient and the radio signal gets larger. That's why with radio transmitters the ground is actually quite important. So this is great, but there is one problem with that. And the problem we have is a component called the diode. Now the diode will only let electricity flow one way. So electricity can flow that way, but it can't flow the other way. The diode will stop it flowing the other way. Now then, power supplies have got diodes because the main supply is AC and the diode is what converts it to DC. So here's a simplified version of a power supply. So we have our 120 volts, 60 hertz in. It then gets transformed down to 12 volts, but it's still 60 hertz AC. So our diode will again chop off the top half. We now have 12 volts DC with a 60 hertz ripple on it. The capacitor will then store the electricity. So basically the diode will conduct that way. It will go out and also charge the capacitor up. And then when the electricity tries to go the other way, which it can't, that capacitor will then take over and continue to supply the current until the waveform is the correct way to then charge the capacitor and then supply the voltage. Okay, now the problem with this, of course, is that as you know, because our diode only conducts one way, if we have our transmitter set up here, then what happens, we have, if we start off with the capacitor supplying the transmitter and the electricity going the other way, we have a waveform, we have our signal here. However, when the electricity then flows that way, the diode conducts. So the diode will let electricity flow that way, but whilst it's open and electricity flow that way, the RF can go back through it into a great big ground connection called the house wiring. So when this happens, the transmitter then becomes more efficient and gives out a higher RF. Now when the AC then goes back, the diode stops conducting. So of course what happens, because the diode is not conducting anymore, the electricity, the RF signal from the transmitter can't jump back because the diode is not conducting anymore. That effectively disconnects this great big earth called your house wiring, so then the signal drops down again, and it stays down until the AC changes direction. Then the diode conducts again and then effectively lets the RF go back through this big ground connection, and then of course the RF goes up. So when you were listening on your receiver, don't forget your receiver is converting this to audio, by chopping off the bottom half. So what you get on your audio signal, you get a low voltage when the diode is not conducting, and then a higher voltage as it conducts. So what this does, this superimposes the 60 hertz mains audio signal, which is your hum, onto your radio wave. Now then, there's various methods of getting rid of this. When we sell our transmitters, we actually have a special power supply, and again this is simplified. We have a capacitor across the diode. So what happens, our transmitter gives a good signal as the diode is conducting forwards, because the RF is getting to the ground of your house wiring. But when the electricity flows the other way and the diode doesn't do anything, this capacitor takes over, and the capacitor continues to let the radio frequency waves go to your house wiring. So what that does, that means that you always have a ground connection no matter what way the electricity is going. So that gets rid of the hum. But unfortunately, it's not that easy, because depending on how your house wiring is done and what you have connected, the hum could still be there. So for example, if on the same circuit, okay, and here's our house wiring, if on the same circuit you've also got, say for example, an LCD TV hooked up, and then somewhere else in that circuit you got your computer or laptop or whatever sort connected, you still have a problem, because you got your ground of your house wiring, but what happens when these diodes start to conduct, it then gives you additional ground. So that additional ground actually makes that signal higher still. So basically all the other stuff hooked up to your mains wiring has got the same problem. So there's various ways around this. You could try a different circuit, because normally you have a fuse box and you have various like circuits going to various fuses. You could try a different circuit. You could even try a different location. You could try perhaps mounting the transmitter in like a shed or somewhere separate to the house, or try an outside mounting. It even varies from room to room. Sometimes you could be in one room and get practically no hum, and you could be in another room and get loads of hum. Here in the basement we do have a hum issue, but as soon as we run the transmitter in an upstairs room, the hum goes. So it's an awkward one to get rid of, and in extreme cases you might possibly have to look at perhaps battery operation completely separate from the house wiring, or maybe even run a mains lead to like again a separate location, and maybe have like a filter or a choking line. So hopefully that explains what causes hum and how challenging it can be to get rid of. But with persistence it can be done. We've moved to several locations. A while back we were actually living in Gainesville for a little while, and we had absolutely no issues at all with hum. But back here in Berkeley it is a bit of a problem. But again, using the correct wire main circuit, and by playing about a little we got rid of it. So I hope that helps, explains what causes hum, and hopefully ideas to get rid of it.